Okay, so before I start, I just want to tell you two things to balance your expectations from this talk. We cannot, for reasons of time, of course, go into details of. We see many complex things. I say complex because they are not simple. Okay, so we are not going to details of each and everything that we see here. I try to give explanations for some of them, but not for all of them. So this is the first thing. The second thing is that the slides that you're going to see are really ugly. Okay, so do not expect anything fancy or having. They're really bad. Okay, so sorry for that. So let's start. Really fast, who am I? I'm currently assistant professor in the University di Bicocca, data science and artificial intelligence. My research area is in explainable AI and natural language processing, and I'm really bad in chess. So if you want to try, I'm here. So let's go and start with this argument because, I mean, I think from the title you already saw there are many pieces that each of them has a word inside, right? Generative models, privacy, utility, balancing these things. Okay, so what we do is to make sure that. Again, in a really high level, okay, but we agree what does it mean? What is a generative model? Anyone can tell me what is a generative model? I like this kind of questions. So, okay, if we have generative models, which we have, okay, and I'm super sure that all of you use them on a daily basis, right? Okay, so if there are generative models, should be some non-generative models. Can you tell me what are these non-generative models? Traditional machine learning models. Good. Can you tell me the difference? Okay. But what makes them traditional? Why they are not generative? Because they are not good enough, because they are not.
Because you have a constrained prediction space, more constrained prediction space.
Okay. Yes, that's a nice way to look at it. Good. Anyone else? I know you're not here to have a lecture. I know that. Okay. But again, it's important that we make sure that we are on the same page. Okay. So generative models. Let's see. We have generative models, we have discriminative models. And really generally speaking, because I know that's not correct, but what is the difference? It's not so easy. It's not, the definition is not that accurate. So what I wanted to say, tell you here, that discriminative models, okay, as our friend mentioned, traditional models, they try to make boundaries, to decide, to predict, to label. Take a data set and say, okay, giving this data set, the output is that. They are conditional. Okay, so this is traditional machine learning is about. Again, don't hate me if I'm not using the terms in the exactly, let's say, precise semantic of it. Okay, but so. Discriminative models try to decide, try to make boundaries. Generative models, they don't care about this. There's not like, give me an X and I will give you Y, okay? It's, give me X, give me Y, and I try to understand the joint probability. What is the probability of having a Y if we start from this X? And again, it's not that easy. Let's say the distinction is not always like this. We have some, let's say, kinds of generative models that actually are conditional, like autoregressive, ChatGPT. It goes forward based on the previous word. Okay, so it's kind of conditional. We have Markov models that they are generative, and they are generative, but they also use conditional probabilities. And it's not super, let's say, related to this topic, but can anyone tell me when generative models were born? Is it 2 years, 10 years, 100 years?
15 years ago.
I can't see who's saying it. Okay, sorry, now I see you. Okay, 10, 15. That.
Even more, but let's say the transformer that are the biggest
Okay.
things in the generative models.
Okay.
2015, if I remember correctly. Maybe they got invented a little early, but I don't think they have 30 years of history.
Okay. Yes, I'm sorry, but they are actually really old. And that's the thing that I normally use this to, let's say, make people hate me. I try to say, okay, when was born? It's November 22. No, that was ChatGPT, okay? And the generative, the topic of generative models, as our friend is mentioning here, like Markov chain, hidden Markov chain models, they're actually really old, really old. They are classic models. Naive-based model, that can be generative. So anything that can generate input based on what it saw before can be generative. So they are not new at all. Pardon me. I know that you don't like to hear it, okay? They are not new. The only reason that we have all this hype now is because layperson can talk with it. And that's it. It's not because like it's the biggest revolution of the world. But we are not here to criticize the generative models. They are nice. I use them. You use them. Let's go for it like this. Okay, so generative AI, generative models, discriminative models. So again, generally speaking, the difference is between their scope. Good. How generative models, though, create, how they generate, okay? Because we are saying that the name is generative model. And this generation thing, where does it come from? I repeat, make sure that I repeat it in each and every slide, okay? That I'm generalizing a bit too much, but we have the time that we have. So generally speaking, we can say that somehow we have these 5 types of methods to generate data, generate something that we see that it's not always data in that sense. So, any of you is familiar with GANs or autoregressive models, VAE, okay, diffusion models, energy-based models. Okay, so each of these category family of methods, so when we say adversarial methods, it's not like there's one algorithm that does it in that way. There's a big family, especially in that nice guys, adversarial methods. It's a really, really big family. And whatever model you choose from that family, it has many children, okay? They're a big family, a nice family. Okay, so I don't go into details of how they do it, okay? But each of them has its own way. One of them tries to, let's say, generate data, adding noise. Starting from adding noise is something else that we get to that. Like diffusion model starts from noise and say, okay, what should I do? How should I change it to make it look like one of my input data? Then we have variational methods that start from space. Let's input a space, take the data in another space, and then try to reconstruct it to create some outputs. Okay, and like this. Okay, so I try to go a bit fast on this, let's say, slide. If we have time, if you want, I can come back and explain a bit more. But we are not here today to understand how exactly generative models work. I think you already know that, okay? So it's just one was like a reminder. So let's do a recap. How we are using generative models, except creating Ghibli style and asking ChatGPT how many R's are in strawberries. How exactly you're using it in your company, in your research, in your work? I don't know. If not like these things, I know it's a really not so nice question, okay? I'm not judging, but please. Generating code. Okay, that's more fair and that's more decent. Good. Anything else?
Getting wrong and hallucinated answers.
Getting, sorry?
Getting wrong and hallucinated answers.
Good. Yeah, that's a side effect. You have it. Anyone else? How you use generative models?
We have a bunch of images for the banners.
Okay.
And we need AI to give us the categorization. For example, like, do we have text here? Do we have
Okay.
call to action button? Do we have this and that? So we give them like a number of categories for him to check all of the images and give us.
Or her. Him or her.
Oh yeah.
I'm kidding. No, that's my glitch, and every time I talk about this, and I say, and he does this, and so, yeah, she does this, we don't know. I'm kidding. Okay, good. Actually, I was expecting somehow not, but I wasn't expecting. All of your examples are actually good examples, because unfortunately, I see a much hype about these kind of outputs and say, you created a woman that had 3 fingers. Wow, we are dying. Who cares? Who cares? Okay, really. But what almost all these examples had in common was that you are using it to generate content. Okay, in your case, you are not generating content. You are actually using it for a downstream task, which is good. Okay, but again, generally speaking, we can. Oh no, he's preparing his timing cards to show me. We can somehow put different applications of generative AI in 3 big families, really big, okay? So first one is content generation. We are all familiar with this, right? I use it every day. Like, I'm not answering my emails since I don't know how many months. Okay, so generate content. It's fun, it's nice, it's kind of work. It somehow work. But then we have 2 other categories that I think they are somehow going to the corner, pushing to the corner, being pushed to the corner. You find the correct way to say it. So the second one, which is actually one of my secondary research areas, is generating synthetic data. So you have your input, then you want to generate data which looks like the input, but it's not. It's not equal, let's say. Okay, so synthesizing data. The third category, which in my opinion is one of the most, let's say, complex categories in these 3, okay, is regenerate a behavior. So user behavior. So you can generate a model that, for example, in A/B test, you can say, okay, I have this and that, and instead of using it on, let's say, real people, you use your generated person to answer that. I prefer this because this and that. Okay, but we are not going to, how much time we have? Okay, 15 minutes. So the reason we put these categories here is to arrive to our privacy thing. So, no, there's no air quote for that. Privacy, we need it, it's nice. Privacy. And where we need privacy, which of these 3, in your opinion? All of them, yeah. All of them, in some of them a bit more. Honestly, I mean, if someone tells me that the cat looks like me and I'm angry about it, okay, you are not going to die, most probably, hopefully. But there can be really big issues of privacy in, for example, the content generation, yes, but in the synthetic data sets and also in behaviors. So we focus on the second one, creating synthetic data. So we have a data set, okay. Any example, can you think of any example of when we can use synthetic data?
To build a great classifier for sentiment analysis.
Okay, but why can't you use your actual data?
Because they need more.
Okay, good, fair enough. Anyone else? Synthetic data?
Personal data such as healthcare.
Nice, okay. Marketing analysis. But my question is, which both of you are correct. My question is, why can't we use our actual data? We close them in a box, no one can see them. What is the problem of that?
Most of the time anyway you have to anonymize it.
It's always you, okay, so.
Most of the time anyway you have to anonymize it because maybe you don't deal with that kind of data without the arrangement of the users.
Okay. And you think,
At the end you do it, but you're asking for that.
yeah. Okay, so you think that creating synthetic data can resolve that, right? Can help with that. Good. Let's see here. Who cares about privacy? There are some examples, some of them unfortunately are real, that when generative models unwantedly, let's say to be nice, leaked some information, some data, okay? For example, especially the family of GAN, okay, that used health data to generate some, let's say, synthetic behavior of some patients, and in the midway they just gave out also information of people, okay, real information. Or emails, phone numbers, API keys. That's actually was a routine thing like 1 year ago to say, then there is a thing that API key was leaked because of this and that. And yeah, and maybe one of the most severe cases is that when we when we are working with real demographic data. So imagine the data that EStat work with, the National Statistic Institution. I never said it in English. They, in theory, not in theory, they have information of each of us in this room, and they have it in a safe place, and that's a really nice thing, okay? And for exactly privacy reasons, they don't just give you almost in any case this information, even if you want for research. They say there is a private data, we cannot just, let's say, give this data for whatever reason that you think that you can use and to create models, to predict. The data are private. Privacy, you can't have them. That's it. End of the day. And actually, there are teams, as far as I know, in STAT that work on this thing, and the specific teams that work on data privacy, synthetic data, private synthetic data, okay? But again, that would be a real disaster. Imagine that someone can have that data, okay? Okay, 10 minutes. And what we can do with that data, okay? So now I go faster. So I think until here, I actually didn't say that much, because I think you already know these things. We have generative models. We have privacy. We like privacy. We want to have privacy. Good. What are the ways to have the privacy? So to preserve privacy, what can we do? Don't read it. Tell me if you want, please. What do you think? How you think we can add privacy to our data? So our friend mentioned anonymization. That's one way, right? So you have a data set. Imagine our data, okay? There is codice fiscale, the fiscal code. There is salary, age, gender, whatever. One way is to remove the codice fiscale, right? Another way is to somehow change it. So this is the, let's say, one of the easiest when we want to do it. When we want to assess that actually does it work, it gets a bit tricky because they are easy to do, but normally the performance is not that good. Anyone knows the New York taxi data of 2014? That one thing, so you know it. It's actually, I just put 30 seconds. So what they did, a guy, based on some laws that is in the United States, that you can ask for public data, asked for this data of all drivers in New York City with starting and ending locations, okay, and deferred how much they asked for it for the customer. So all this detailed data, and of course, they didn't give you the ID, the real ID of the driver, because there was another database that says, okay, ID number 1 is this, ID number 2. So they changed it. I think they had used the hash function or something like that to change it, and they published it. So the data is anonymized. You see a line, and there is no way for you to say, who is that guy? Unfortunately, it wasn't the case. Unfortunately, I don't know the name, but a guy understood how they hashed these IDs because there was an error, and because when the ID was missing, they were putting 0, okay? And the guy did it like a sum and saw that that specific ID is doing really well. Is let's say, have a high income. So I said, okay, it should be 0, that code. So find the function, find all the IDs, match them together, and found all that private information of that people. So anonymization is a nice thing to do. It's an easy thing to do somehow. It's not so, let's say, performance all the time. Another way is adding noise. Oh, that fast. 5 minutes. Another way is to add noise. So we take the real data, we add a bit of noise, we change it a bit. In theory, we are still close to input data, but not exactly. We are not exactly the same thing, right? Okay. Really fast, really broad categories, how we can achieve, let's say, privacy. The first one, and the most common one, is differential privacy. Anyone does that? You do. Sorry for that. I mean, it's you have some headaches. I think it's when you read about it the first time, it's easy. You add some noises, and we are all happy. And it's a nightmare if you actually want to guarantee the privacy from a mathematical point of view. It's not like add something and you're good. So differential privacy, in theory, guarantees the privacy and guarantees that no one single record can alter the output. Another way is PATE group, private aggregation of teacher ensembles, where student models don't see the data. There are some teacher models that look at the data, learn from it, and then teach another model, adding some noise. So the end, let's say, model won't see the data, the real data. Federated learning, when you don't share data, you share a model performance through different nodes, 2 minutes, and synthetic data. You see? Is there anything that has too much privacy? Yes, no? Yeah?
Well, if you add noise to the training data, then you might lose some performance.
Thank you. Yeah, that's the thing. I mean, privacy is good. We like it. We want it. We're happy about it. We are happy about it. But we can unfortunately have too much privacy, okay? And that happens, when that happens, we are lowering our utility performance. Look at this very simple case, iris data set. So I took the data set, I add some noise, and in each, there are 3 levels of noise, okay? So the blue one is the real data set, and the yellow one is the generated one. So you see in the first place, when we have noise standard deviation of 0.1, okay? Let's don't go in the details of what is Westersian distance and SNR. There are two ways to assess privacy and utility. And you see, when we get there, the privacy goes up. So we are super happy about it. No one will ever understand what was the real data. And that's also a problem. Which is the best one? Don't say the middle one. There is no easy answer. It depends what you want to do, what is more important? Again, for eStats, the most important thing is privacy. Privacy, privacy, privacy. They don't want, and which is a really nice thing, I thank them, they don't want to leak any information, any private data. So privacy, all the time. Really fast, really. So how we can measure it? Because it's not like it's subjective things and you say, oh, okay, here it seems like too much, let's say, it's too wide, so we need to measure it in a numerical way, okay? So there are many different categories and metrics to do that, but in my opinion, 3 main categories are privacy metrics, sanity checks, and statistical metrics. Privacy metrics, okay, they somehow quantify how private is your data set, the synthetic one. And sanity check and statistical metrics try to say, this was your initial data, this is your output data, how much they overlap. So look at the first one. You see here, real data and original data actually kinda completely overlap. The second one didn't do a good job. Last slide. Fast recap. So we know that we have generative models, we have non-generative models. What is the difference? We know that there are 3 different types of generative models, okay? Content generation, synthetic data, and behavior simulation. And all of them can have privacy issues. And we know that improving privacy means decreasing utility and vice versa. So what is the correct point? It depends what you want to do. What are your data? Thank you. So that was it.
Thank you very much, Navid.
Thank you.
Time only for one question, 2 minutes. If using generated data to anonymize, wouldn't that have the same risk of leaking training data?
So if I create synthetic data, is there any risk that I anyway leak data, leak information? That was the question.
Yes.
Of course there is. Unfortunately there is. I mean, that's why we have all these, let's say, different metrics to understand, okay, so you created synthetic data, so it means that none of these data points, new data points, are too close to the initial data point. So yes, there is unfortunately a risk for that. That's why we need to evaluate the whole, let's say, generation process.
Okay, just the last question. Could you briefly explain the concept of latent space in generative models in 30 seconds? I don't know.
Not even who created that thing. Okay, so I try to be fast. In 30 seconds. Our data almost always has more than 2 spaces, 2 dimensions. When we have 2 dimensions, we can draw it. When we have 3 dimensions, we can imagine it. When we have more than 3, we can't even imagine that, okay? Our data, most of the time, has hundreds, depending on your input data, dimensions. So latent space is when you take that input, okay? So imagine that your input is on 3-dimensional space, okay? You transfer it into another dimension. So you start from some dimension, you transfer it to another dimension, another space, okay? Your data points are still there. Now they have or more or less information with respect to the initial point, okay? For example, these VAE models, they try to start from input, take it to the latent space, add a bit of noise, and take it back here. And when you do it, you see that the initial point and the output point, they are not exactly the same thing, which is our point. We want to add a bit of noise. So transfer, retransfer, adding a bit of noise in this cycle.
Okay.
Hopefully it was clear.
Okay, thank you so much, Navid.
Thank you.
Excellent talk. If you have more questions,
It's
please
my
feel
email.
free to continue the conversation outside, so we can get ready for the next session. Coming up next, Alessandra Bilardi will be presenting the art of data visualization.
Thank you. Thank you.